Assalamualaikum warahmatullahi wabarakatuh. My name is Divo Silalahi. I am a former PhD student in applied and computational statistics under Professor Dr. Hafsah Midi and all member Dr. Muhammad Safi and then Dr. Jayanti and also the external member is Dr. Jenper Kaliman. First of all, I would like to say thank you for these awards. Here I received the awards about the Anugerah Excellence in Scholarly Publication 2020. So I would like to address this award also to my professor and all member. And also I would like to encourage all the students who are in still ongoing or just start the semester to publish your paper soon, your findings, so then you can celebrate with everything. Okay, first of all, I would like to share my research. So I will start to share screen and I hope everyone can see. So, okay, I will full screen. Okay, thank you. So my research is about developing several robust procedure on partial least square regression method and application on near infrared spectral data. So for your information, near infrared is one of the spatial data which is contained of a number of wavelength where we consider this as independent variable and also with the number of observation where we consider this as the n number which is all is considered also as a hyper dimensional problem. So I will start by my presentation about with I and my research assistant. This is was done conducted in the Riau province, Indonesia. So this data collection is about 6 months. So I spent one semester for this research purpose. So we collect the spectral data from the bunches, the fruit, in order to get the data. So the outline of this presentation is about there are 5 chapters. The first is about introduction. The second is about the main objective. The third is about the discussion, research contribution, and then the fourth conclusion, future research, and also my some publication. So the first of is about what is the NIR spectral data. So in the plural we call as spectral, while in the single form is we call as a singular. So this spectral is the interaction between the physical matter of the sample with the electromagnetic spectrum. So means that when we have a sample here, so we pass the light over here. So the light that absorb and then the transmitted from the sample to the sensor is we call this called as interaction. So the calculation of the interaction can be done by any the most famous is by using the Beer-Lambert law that we see as below by Stewart 2004. So the development and important contribution to tackle the challenges, the scientific big data, especially in the vibrational spectroscopy technique, then the famous one and only is the partial least square regression. This is different with the principal component analysis, where the covariance is only considered by the x independent variable by partial square summarize the covariance between x and y in here become one new latent variable. So this is the step that we did. The first is we collect the bunches and then we use our own spectra, portable spectra. This is made by quality spec from the ASD USA, and then we scan the fruit mesocarp here, and then we got the spectra. Our objective is to find out how many percent the oil content in the buns by using this correlation of the spectra to the reference that we got it from the wet chemistry laboratory. So this is the one how it look like. So the upper one is here, and then this is the full mesocarp. This is the dry ground mesocarp, and then you see that the width of the spectral is very tight, starting from here to this is quite wider. While here quite tight. This is due to the because this is really fresh mesocarp of the fruit, and then this one is a dried ground. This is already in the like in the powder, so is a very the particle is very small, And then here is the frequency distribution of the data itself, where the data we use as the Y. Here we consider we do not to use the Y simultaneously, but we use it as parent. Y1 is ODM, oil to dry mesocarp, and then oil to wet mesocarp and fat fatty acid. The difference between the dry and wet here is the oil to wet mesocarp. We consider that the calculation of the percent of the oil is still included the moisture basis here. Okay, because I have the 15 minutes and I will start to speed up this presentation. So the first problem phase in the NIR spectral data. So before we go to the objective and then we go by what is the main problem is. So we start by the problem. The first is due to the whole number of spectrum, of course, this is a risk of multicollinearity and heteroscedasticity. The second is the variability of the spectrum measurement or the experimental error. This result on the parallel shifting or the slope. And then this is the source of the risk for contamination of the outlier and high leverage point. The third is the difficulty of the absorbent interpretability. So this is we related this to the irrelevant wavelengths. This is one of the main problem normally when we include all the wavelengths where the irrelevant wavelengths is included, so the computational leads will be cost. And then the additive and multiplicative effect and scattering effect in the spectral data. So due to this kind of the problem, so before we start process this spectra, we have to conduct the pre-processing spectra solve. And then we also has the problem with computational intensive, where all the variables still have equally probability to contribute in the model. And then we have also the nonlinear behavior. This nonlinear behavior due to the collective spectra are often composed of the complex aperture and many overlapping peaks, which result to irregular data may exist. And then the last, not the least, anyway, this is the robustness issue. We know that the partial square regression is the one that become famous and normal used by the all chemometricians. So by this, we try to introduce a new technique where this really high promising, where we consider the robustness of person of this technique. So by the introduction here, another is when we deal with the partial square, we know that the fitted model perform poorly when outlier and HLP still exists. And then the model is sensitive to the number of partial square components. And then the no variable selection procedure is applied. So this all is the weakness of the partial square. And then the method fails to discover to the non-linear structure. So these all are still open problem. Even you have some idea, so you can still do with some your solution. So before we start, again, I would like to show you how the partial square regression look like. It seems like the multiple regression is do like this, but the main issue is that when we get the estimator for the beta here, so the normally by using least square method is look like this. While if we take summarization of the covariant with the x to the y, so the estimator of the b, the beta, is become like this. So this is the summarizing the x and the y, and also by considering the sum component here, and also the some initial of the y. In here, in the case of the simultaneous, but anyway, we start by only using a single. So this is will equals to the y. So following and the Nepal algorithm, then we start by assuming x to y as a mean center and scale, and then we repeat all the process under convergence, starting by normalization of the weighing, and then we do with the loading here, and then by we normalize it again, and then we calculate the estimator, and then we compute the residual both in the x and then u. And then the pre-treatment of the NIR. So we know that in the universe there are many of the treatment of NIR, but some of my research and also some of the reference they say that the SNV, which is row oriented transformation, and also the multiplicative additive spectral correction is the two of the famous where this also still need to be combined by other technique, what we call as a detraining. This is to remove the covariancy and baseline offset of the spectra. And after that, the derivative of the smoothing. This is to minimize the error and the noise that maybe appear due to the instrumentation or the some noises coming from the sunlight. And then we also know that the weighted average partially square regression is by Zhang. This is also the one of the modification of the partially square, where the Zhang introduced this kind of technique by making the weighted average in the all of the possible of partially square. So they are not one only, but by assembling, starting by the first no the first two, and then to the rest of the number of possible of partially square regression. And then the variable selection method. So the variable selection method also has some, I say that the strengths and then the weakness. This variable selection method, there are many of the technique also. The first popular by the classical, we call it as variable important projection. This variable important projection is done by looking at this, where this is the sum or square of the predictive component here, and then this is sum of also predictive component, where it start by taking from G to the from G1 is our number of our start number of the partially square, starting the number of component, and then to the rest of the L. And then we have Monte Carlo uninformative variable elimination. This is one of the famous also. This is applying the Monte Carlo simulation, where the number of artificial of the noise is also applied in order to see the robustness of the wavelengths, and then to cut and eliminate the irrelevant wavelengths in the model. And then we have also kernel partially square regression. This one of the technique also is very famous, where this take some opportunity to handle irregular space in the matrix, where the input matrix normally is done by normal of the spectra, but here is mapped to the nonlinear to the higher dimension of the F. So if we see the coefficient matrix of the kernel partial regression, that we see is in a higher dimension of F can be made by using like this formula, where this psi dot is represent the nonlinear mapping function in the input space to the kernel. So how we identify the vertical outlier and the high leverage point, because we understand that, because when we talk about the robust, so there are also these two issues where this is outlier or the high leverage point. So the first technique that also normally is done by using the M estimate, where this apply to the PLS by modifying the row wave function through iterative reweighting. So the observation which identify as the outlier that will be minimized or will be eliminated from the calculation. So by using this weighting, as we see from here, this weight then will be confirmed by the row base. While when we have the column base, so the one is that normally that we do is by applying the in the x dimension. So to identify this, as before, the Chanel already in his PRM also combine the row base and then the dimensional X. So from here, so we can see that all of this calculation also will related to the what observation that will be follow in the model. So another probability technique I also would like to appreciate and then acknowledge my professor, Prof. Hafsa, using his own or her own outstanding formula, diagnostic robust general potential from here. where the robust cutoff here by the potential is greater than the median here, so it will be say as identified as a high leverage point. So our main objective here is to foremost objective is to develop a new robust predictive method that is resistant to outlier and high leverage point. And the second is to establish new partially square regression model based on modified weighted average strategy. And then we improvise the robust wavelength selection method. And after that, we formulate the nonlinear solution to the partially square regression method using the kernel-based learning. So if we make the illustration of this main objective, so we would like to make a new hybrid flexible robust by incorporating of these four proposal of the strengthness of the formulation. So we discuss this as we arrange and this discussion into some chapter. So we start by research contribution 1, 2, and then 3, and then 4 and 5. So there are 5 chapter here, and we delightful to say that all these chapter already published in the journal. So the first is about the research contribution 1. How we construct the robust generalized multiplicative scatter correction algorithm on the pretreatment. So on the pretreatment of spectra, we propose this method. The first is we calculate the initial robust weights using the partial regression method by Snell. And then we normalize the score matrix of the V and then the column factor of the Y in step 1. And as the matrix is the RGP algorithm, and then to calculate another row weights. So we have two row weights here. So the row-based generalized weight is a kind of this formula. We compute the column weights by using the Monte Carlo and multivariable elimination using updated remaining set in the tree, and then we calculate the robust column factor M of all spectra using the medium spectra. And then the 6, and then we regress every point X to the column factor M using the weighted square regression, and then we calculate the corrected spectra. After that, we treat this with the derivative smoothing to replace the row spectra with the SIG GMSC. So this is how it's look like. We apply the Monte Carlo simulation with the 3 sample size of 40, 160, and 400, and we have a 3 different level of outlier and high leverage point, starting from the 0.05 to 0.5. As we see from here, our proposed method in G is show a very low error compared to the rest. So the GH is a GMSE and GMSE with the difference 1, the old derivative 1. And we see from here the correction of the spectra from non-treatment to the SNV, GMSE, GMS1 C with first derivative here, SNV, MSC, GMSC second derivative here is look like something like this. So the as we see from before, the GMSC and GMSC with first derivative and look like this. So you can see that in here is really minimizing the all of the spectra. We will see later on by looking at the parameter of statistic, how it look like based on the evaluation. But anyway, this is all the kind of the difference. We see that the GMSE and then our purpose here is really not the spectra is really not affected by any of outlier or the high leverage point here. The green one we call as the contamination of the data. Also from here, the correction is this by before is a 5% contamination. This is we add more by 25% and so on. So we see from the percent of DM, the R square and the SE is become less. So our purpose is the most good one. Also by using another data with the different spectra, also these two are still confirmed compared to the rest. The second contribution is about the robust reliable weighted average partial square regression. So this is the idea of this is how we can make robust partial square regression without applying any number of component used in the model. So The first is we perform the PIM regression using the resampling procedure of K-volt CV to obtain the SPCV, standard error predictor of cross validation, and then apply the 20% of trim SPCV to get the first weights. And then we calculate the second weights of CG using PIM coefficient as reliability value of each variable. Then we transform the second weights into diagonal of the omega, this diagonal omega, and become a new scale input metric as here. And then we assign this new input metric in the PM regression to recalculate the new component from here, and then we calculate the prediction of the y that we have, and then the x new variable, and then the first weights into this new formula. So as we see from here, the calculation is based on really weighted average, but in our proposal is the weighted average is a include only the robust of the data where the outlier and high reference point are removed from the calculation. So let's see from what happened when we do with the Monte Carlo simulation. So from here with different sample size, three level of number predictor and three level of input variable and three level of outlier and high S reference point. As we see from here is our proposal where the D is the lowest with no outlier high level point, absolutely is close to the initial technique. When we have the outlier here 5% and 20%, our propose the first is modified with the average here, and then our final robust version is look very promising compared to the rest. So as we see from here, how the predictor again the actual value on the simulated data, we start by this to see that how it look like. Though here we see that the modified weighted average and the robust fashion of the weighted average is the look very promising, where even there is contamination here, but the line regression is not affected, really not affected. So how is the conclusion in the parameter statistic? So by using two data set, percent ODM and FFK, we see that our rest of our proposed model is low promising compared to the rest, both of using the square error or even using the R square, RM square, and the NPLS that we see from here, it will always static because we use weighted average. And then the third contribution is about the robust wavelength selection, and how here we remove the variable selection means that the most irrelevant not included in the model. So the first is we calculate the total of orthogonal partial square VIP score. This is the existing of the orthogonal partial square regression VIP, where this VIP is calculated by this. This M is a number of this M is a number of this one, the predictor of the orthogonal, and then the predicted one, and then this is the formulation of the some square of variation in the orthogonal. This is also some square in the Y of orthogonal, and Y this is the prediction of the some square of variation of the X, and then this is on the Y. So the number two is determine the input scaling variable by using the omega, where when we find this VIP, then we put this in the lambda as a lambda by diagonal matrices of the omega. Then we calculate the new initial scale by using this formula and perform the make UV using the initial X and use the produced variable CG as weights to rescale the original input X, and then use the final XCG, the new X star here as a new scale initial X star is input metric in partial square regression. So we apply also the Monte Carlo simulation here by using a different number of sample size, level of predictor, and 5 level of input variable, and then it's look like this. So we see from here the modified VIP is become lower compared to the rest, where this already removing the irrelevant variable. Whereas we see from here, when we have important variable only 10%, is really downscale here, and then the error is very small. When we have the variable is more, absolutely it's become close to the rest. While when we only have the rest of this variable, is become like this. And then time consuming performance when we deal with only spatial or the only this kind of the formulation. So we start by um, modified VIP, that this is our proposal. As we see from here, this the proposal is a very good, where our computational speed are very efficient. So how it look like in the data set? So this is the data set here. The error is less compared to the rest, with the number of PLS also less compared to the rest, and then the R square also looks so good compared to the rest. And then there is a contribution for how we handle the irregular spacing of the data. So the first of all, we apply the kind of partial diagnostic robust potential with high resistance to multiple outlier and high leverage point. We start by this. The first is we apply nonlinear mapping function. The mapping starts by the psi replacing the original SI with the new of mapping function here. We compute the kernel gram matrix, and then we centralize the kernel gram matrix K, and then we identify matrix I as the initial weights or omega on the centralized kernel matrix to get the weighted K and output factor this. And then we regress K on the Y to obtain the weights, and then apply the normalization and rename it as a new factor of the G, and then calculate the Y weights by regression and project YG on CG. And then we determine the YG and VG improvement using this kind of formula. And then we deflate the kernel and the Y. We continue to step 4 until all the LPLS components are determined. And then the new calculated latent variable V as nonlinear is used as the new input space in the next robustness procedure. And then by each point, the pairing of these component score here, we calculate the robust Malanobis, and then we use cut-off point criteria to determine the suspected outlier in high leverage point on each I point of robust Malanobis, and then we compute the generalized potential, the DGRP, DRGP for each I point to detect the high leverage point here, and we continue to step 2 to calculate the new weighted of our kernel and then the dependent variable. So by using the Monte simulation, then again by applying different sample size, 3-level number of predictor, 3-level of outlier and high leverage point, as it look like this. So we see from here that our kernel DRGP is look very small error compared to the rest. And see from here that we apply the measurement and the versus the predicted, when the number of high leverage point here increasing by starting by let's say for to see by the 25% here, it start by here, and then we see that our proposal of kernel DRGP is really not affected, while the rest is really affected with no pattern, clear pattern surprise in the formulation. So how the statistical measure apply here? And we see from here our proposed kernel partial DRGP is better compared to the rest. It's also with different data set, it's still outperformed. And then the last of our finding is how if we apply the kernel partial GM6 with high resistance to multiple outlier and high leverage point. So as we know, as before, we start only by applying the kernel of the RGB. So here, see here, we start by applying the GM6 to see the high resistance of a multiple outlier. This become our first initial program. I mean that first initial formula. When after that we apply a new robust, where this high leverage point can be classified into two: the good and the bad, where we only consider the bad leverage point to be removed in the formulation. So this is the normal of the GM6 in how the estimator solution look like this, and then this is how we perform the GM6 to the partial robust GM6. So and then the kernel version of the partial GM6 we use the outer product here by using n times n kernel matrix is equal matrix, and then the new ways we just follow by this occurrence formula by omega times the kernel and omega with the element in the diagonal equals to the generalized weight in the partial robust GM6. And how it look like? If we see from here, they see with different kind of scenarios, our kernel partial robust GM6 is a different, is a really less error compared to the classical. As we see from here also, even there is multiple outlier at high levels point here, so it's really not affected. Even the outlier here is not affected. So the conclusion is our proposal is very good compared to the rest. So my general conclusion here is in the pre-processing of NIR spectral data, the proposed GMC method give the benefit to remove the scattering effect and noise that may impair to the accuracy of the PLS7 model. And then the second is the purpose of the RRWA PLS with weighted average strategy doesn't require suitable optimum number of PLS component as is usual. And then we improve the model interpretability and increase the convergence speed of the algorithm. And to discover the significant nonlinear characteristic and irregular behavior, the purpose of our kernel partial DLGP was superior compared to the rest. And then this purpose improve have its own potential. But anyway, this used to bring superior and robust PLS method. So we say that there is no specific rule which one is the most priority. But anyway, this and the important of that necessity, this is belong to what we focus. But anyway, here is our whole proposal, and then we also give another robust procedure by using HLP into good and bad, as what I mentioned before. So we are in here now. We have proposed our new technique, and this finding already cited in our finding. We published this already, where the new technique, this is encounter the last KPDRGP. This new technique can classify HLP into good and bad, so we only consider the bad to be removed in the formulation, also the outlier. And then the last is the automation of sensor by merging all the proposed improvement into single model is highly recommended, absolutely, than applying up this method parallelly, exactly. And then this is all our journal publication. I would like to acknowledge again my Professor Samidi and Dr. Jayanti, and then Dr. Muhammad Safi, and also Dr. Jenper Kaliman as external member. The first is was published on 12 May 2018. It's in the GCR Q2, and our second is in December 2020 GCR also Q2 in the symmetry. This is in the Science Direct. This is MDPI. This MDPI Q1 is published on 3 September. And then we also have the Scopus here in the Alien. This is now is Alien is already cited in the Q2 or Q3 something. And then we have also the Scopus. This is already accepted in the Thai Journal of Mathematics by 2020. And then we as because I'm so sorry to say that this our new finding was present by the first of the 2021 during my Viva here. But anyway, on March we have published, and we are very happy this into the Symmetry Journal, and I can conclude that all the journal or the chapter in my dissertation already published totally. So this is my conference proceeding. I also joined some proceeding with some technique support method during the University of the Philippines Banos in the IP, or this is during the Langkawi Inspem conference, also. This is in Technology School November, Indonesia, and then this is in Taksin, Thailand, where my professor become a keynote speaker there. And then in the ISI was Statistic Malaysia, and then I also went to Australia for International Council conference for the near spectral infrared. So this all my presentation. I hope this give you some fruitful idea. And anyway, again, I would like to say everyone here for all the encourage and also all the staff in Inspem, the faculty, and also the School of Graduate Study for good cooperation during my study. So I can graduate with good outstanding. And also, I also thank you for this reward. This also extended to my professor, Prof. Hafsa, and also all the members, Dr. Jayandi, Dr. Muhammad Safi, and then Dr. Jacob and also all my family. Thank you again, and then Assalamualaikum warahmatullahi wabarakatuh.